What's up, little Pythagorons? Today we're going to talk about properties of logs. These are going to be so fun. These ones are actually not bad. You don't have to fight with your calculator a whole bunch. And I don't think they're that bad. Like, you don't do like a whole bunch of like calculating. It's just rewriting stuff. So you don't have to multiply. You don't have to move things to both sides. It's not too bad. So we're going to learn some properties of logarithms, just the same way we did properties of exponentials. And if you remember, exponentials are inverses of logarithms. So some of those same properties are going to be pretty similar. So, all right. So let's go learn some properties and then use them. All right. Our first property is the product rule. So if we remember back to exponentials, if you have something like x squared times x to the third, you add their exponents together. So 2 plus 3 would be x to the fifth, right? So for logarithms, because logarithms come from exponentials, we can use the same rule, and then you don't really have to figure out what the rule is, right? Like someone else figured it out for us, and you just have to like remember how to use it. So if we have a logarithm with some base a, whatever it is, it doesn't matter, it's some number. And inside the logarithm, we have two things being multiplied together, b and c. What we can do is take the log base a and split it into two logs with that same base. The base does not change. Put a plus sign between them, and then we give each term that's being multiplied its own logarithm, and you separate them, and all the logs get added together. So yeah, so let's go see how we can use this, right? Let's do a couple example problems, and then we'll learn another rule. All right, I'm gonna hold off on a. I think is the hardest one because it's like, what do you want me to do with that? So let's look at b first. For b, our log is base 3, so we're gonna set this up with log base 3 plus, how many terms are in our argument? Well, we have 60 times x times y. So because there are 3 pieces to our term, we're going to separate this into 3 logs. So log base 3 plus log base 3 plus one more log base 3. And then each piece of this term gets its own logarithm. So we put the 60 there, we put the x here, we put the y here, and then this is our expanded logarithm. Cool. Okay. So if we do this one, letter C, we're doing log base 4 of x times y times z. So we have 3 pieces in this term, so we need to make it 3 separate logs. So we have log base 4 plus log base 4 plus log base 4. And then each of these gets its own log. We have log base 4 of x plus log base 4 of y plus log base 4 of z. Then for D, we only have 2 terms here, or 2 pieces to this term. It's a monomial. So we're going to make 2 logs. This log doesn't have a base that we can see. So this is the invisible log of 10. But we don't need to write the 10, right? Just like we don't have to put a 1 in front of the x and the y and the z, we can just leave it blank. So we can do log of 18 plus log of z, and everyone who reads this should know that the invisible log is a base 10. If we go back to a, this one is weird because there's nothing to do. It has a base of 10, okay? And it has 6. You can't do anything with that. You could type it into the calculator and get a decimal. But this is not expandable because there's not multiple things. Or actually, let me show you a trick we could use to, if we want to force it to expand, you can, but there's not really a point. You could rewrite this as log of 2 times 3, because 2 times 3 is 6. But you don't do that here, which is why I think you don't have to do it. But you could expand this. You could do log of 3 plus log of 2. Sorry I changed the order on you, but There you go. So that's our product property. Let's look at our power property next. You'll remember if we have x to the third power to the fourth power, if you have something with an exponent to an exponent, the rule says for exponents, you multiply the two numbers together, b times c, or you distribute the c into the internal exponents. So 4 times 3 would be 12. We have a similar thing for logs, where we turn a power into multiplying, right? So if we have a log with any base a, and inside you have something to a power, what you're allowed to do is take your power and you move it in front of the log and multiply the whatever power it was, that's your coefficient, and you multiply that to your log. Again, the base stays the same, and the term inside the b, the base of the argument, will also stay the same. All right, let's go practice. So let's do an easy one first, e. So we have log invisible base 10 of x to the third power. So we can take our 3, throw it in front of the log, and then that is our answer. So we have 3 log of x. Cool. How about f? Here, there's two things we can do. Because the 14 is multiplying to the x and is multiplying to the y to the third power. We can separate this using our product rule. So we're going to have log base 5 of 14 plus log base 5 of x plus log base 5 of y to the third power. Only the y gets the third power because this 3 is inside the parentheses and it's only on the y. If they want all of these to have third powers, they should either... They should either move the 3 to the outside of the parentheses, like that, or they'd have to write it 3, 3, 3. Okay. Here, we can do one more simplification, or maybe a desimplification. We're expanding. We could use our power property and take the exponent and move it in front of the log. So this y one, the 3 can go in front, and then we can take the 3 off the argument. There we go. This would be our answer. Okay. Here, this one is going to expand into 1, 2, 3, 4 logs. And these 3 are going to get coefficients because we're going to move the exponents out in front of the logs. So we're going to have log base 7 of 10 plus, I'm going to leave some room for the coefficient, log base 7 of x to the 5th plus log base 7 of y to the 3rd plus log base 7 of z squared. Then we can take all of our exponents and put them in front of our logarithms. So this would be 5 log base 7 of x with no exponent on it. Here we can move our 3 in front like that. And then here we move our 2 in front. Let me also move the plus sign like that. So this would be our answer. It would be log base 7 of 10 plus 5 times log base 7 of x plus 3 times log base 7 of y plus 2 log base 7 of z. Cool. Easy. Not too bad. No, I hate math. Oh, well. Oh, well, you're going to have to deal with it. Sorry. I don't know why. I really like math. I think math is a lot of fun. I think... I get why you don't like it, though. But I still think it's tight. All right, quotient rule. Here we have same base and 2 exponents. When we had something like this, like we would have x to the 5th over x squared, we could subtract b minus c, top minus bottom. 5 minus 2 is 3, so we could rewrite this as x to the 3rd. So what we're doing here is we're changing division into subtraction. So we can do the same thing with our logarithm. If we have two terms inside that are being divided, we can turn that into subtraction. The important thing here is the denominators all have to go inside logs that have a negative sign in front of them. All right, so let's look at these. We have log base 12 of 7 over x. So we can split this into two log base 12s. And we're going to subtract them because it's dividing. The numerator goes on the top. The denominator goes in the negative log. All right. Here for natural log, we're going to separate this into two natural logs. And we're going to subtract them because we're dividing. The 15x cubed goes in the first one that's positive. Cubed. 15x cubed, not squared. And then we have y, that's kind of hard to see, but it's a 7. So y to the 7th in the negative log because it's in the denominator. Then we can separate this into two logs because we have 15 times x to the third. And then this, we can move the 7 in front of the log. So this will turn into the natural log of 15 plus, because they're multiplying, the natural log of x cubed minus 7 goes in front, the natural log of y. And then the last thing we can do is move our 3 in front of this log. Like that, using our power rule. Cool. There we go. So now we have all three rules. We have power rule, product rule, and quotient rule. There is no adding rule. If you have something like log of x plus y, this is stuck. You can't separate that. That doesn't work. There is no addition rule, unfortunately. So, all right. Let's do two more expanding practices, and then we're going to try going in reverse and taking things that are being added together and then condensing them. And you're going to say, Mr. Barton, you said there isn't one of those. There's not one for the inside of the log. If two logs, though, are doing something, we can go reverse. Okay. So here, we're going to separate the top and the bottom. What we can do, if you're careful, we have 5 times x. So these two are going to be positive because they're in the numerator. And we need to add them together to separate the multiplication. So we could do the ln of 5 plus the natural log of x. Then we can separate our 6 and our y squared. Both of them are going to be negatives because they're in the denominator. So minus the natural log of 6 minus the natural log of y. It would be squared, but we can just throw the squared in front. And this would be our answer. All right, let's look at k, and then we'll do some condensing. So we just have three things here. Y, x squared, and, sorry, did I say y? 35, x cubed, and y. So we're going to separate them by adding because these are being multiplied together. And the one with the x, we're going to go ahead and throw the 3 in front of the log. So we're going to have log of 35 plus, because it's multiplying, the 3 goes in front, log of the base, x, plus log of y. There we go. Expanded. Cool. So now condensing is the same thing. It's all of these rules just in reverse. So the same way we could take two logs that were being divided and separate them like this, we can go the other way and we can stick them back together by going from subtraction to division. And the rule is just if the log is negative, it's going to go on the bottom. So let's look at this. All right, so we have the log, the natural log of 5 plus the natural log of x. Because they're being added, we can condense these into a single log because the bases match. If the bases don't match, you're not allowed to do this. And then where the adding was, we turn it into multiplying. So 5 times x. There we go. Let's try this one. First thing I'm going to do is move the 4 onto this as an exponent. Then I can condense these logs because they're subtracting. This one will go on top because its log is positive. This one will go on the denominator because its log is negative. So we're going to have log base 2 of x on top over y to the 4th. And then all of this fraction is inside the log base 2. All right. This one, we'll do a little more carefully. We'll do it in multiple steps. Let's condense this, and then let's condense this, and then we'll turn it into a fraction. So here, the 2 goes on to the 3. 3 squared is 9. So this is natural log of 9. This is natural log of x. Because they're adding, we're going to multiply. Here, we're going to move our 3 in using the power rule. And then we have y to the 3rd power. So times y to the 3rd power. And it's also being multiplied because of the plus. Then we have minus. Here we have the natural log of 2 plus the natural log of 3. We can multiply these. And then this 5 will go in onto the z like that. So this is going to be the natural log of 2 times 3 would be 6. And then the 5 goes in onto the z, and we have z to the 5th. All right. Now, because these two logs are being subtracted, we can turn this into a single logarithm where this is the top because this is positive, and this is the bottom because it's negative. It will be the natural log of 9xy cubed over 6z to the 5th. That's all inside a single natural log. Let me just make my 9 look like a 9. All right, let's try one more. There should be a parenthesis there. I don't know why there's not. All right, so for here, we're going to put our 5 on our y to make this y to the 5th. We're going to put this 2 on the z to make it z squared. Then we're going to multiply all the arguments together because these are being added. So we're going to have log base 3, because all of them are base 3, of x y to the 5th z squared. Minus, here we have log base 3 of 11 plus log base 3 of 7. So this is going to be minus, because these are adding, we're going to multiply their arguments together. So 11 times 7 is going to be 77. And now because these two logs have the same base and are being subtracted, we can turn it into a single logarithm with the same matching base. And then we can take its arguments, the term here and here, and turn them into division inside the log. So we'll have x y to the 5th on the top, z squared over 77. And this is your answer. All right, that's all of your notes. So I think you are ready for your homework. So go ahead, head back to the WebEx. Let me know that you're done, and I'll open the homework for you. Let me know if you need any help. Have a great day, folks.